All right, I think we can get started. Welcome, everyone. Welcome to our interactive session where we'll demystify what it really takes to implement AI-powered visual inspection in your manufacturing workflow. If you're exploring automation for the first time or looking to scale your existing inspection system, we will cover what kind of defects can be detecting using AI, which products and materials are best suited for AI-based inspection. We're gonna cover how long it typically takes to get started and onboard your products. We're going to cover what typical accuracy rates are, performance benchmarks, and what to expect, while giving tips on integrating with existing workflows and proving ROI. This is going to be an interactive session, as I said, so let's have a look at how you can interact. To submit a question, click on the activities icon in the Google Meet toolbar. Can you see it? It has changed now. It's not this triangle, for example. It's just an icon with some circles. So make sure that you use that to submit any of your questions. And now I'll give it away to Will to start.
Thank you very much, Aline. I think I will do some brief live editing, actually, and switch out this one.
Yes.
Or this one. So, because indeed it has just changed, basically. So this is what you need to click, meeting tools, and then there is the Q&A function. I believe that is the correct one, but you can also use the chat, I believe. Right, very good. So with that out of the way, some live editing right here. Once again, thank you very much here. As Eileen said, the purpose of this one is to give some information. As we titled this webinar, talk a little bit about how to get started. And before we even get to how to get started, we can address why that is a question in the first place. Why is it so difficult? And what's keeping everyone from implementing these technologies that are out there? Why is getting AI and especially machine vision in place? So we'll talk a little bit about the difficulties that we see out there, and then of course address how Zetamotion in particular can help solve these headaches of implementing AI and what it looks like starting with us. So I see there's still people joining. So guys, we want to have this as interactive as possible. So the more this is conversational, the more fun it is for everyone, and the more questions we have, the more interesting information might be shared among people also across different industries. So please do not be shy to ask away, and I'll stop at any moment and give some more insights. Right. So why is it so difficult? Well, it seems so easy. It seems so easy. There's so many tools out there that you can download nowadays. You can try for free. There's OpenCV, of course. There is platforms from Cognex, from Kayens. You can try out Microsoft Azure's custom vision. There's Google AutoML vision. Amazon has the Lookout for vision. There's a lot of items out there, right? And if you look at some of these websites, this one is actually from Azure. It makes it look very easy, right? It says here, create a custom computer vision model in minutes. Use embedded state-of-the-art computer vision, and it's super easy. Just upload a couple of pictures, and out you get amazing inspection, right? So that's the promise, and that's the potential, and that's what everyone sees and knows is the future, and nobody wants to be left behind, right? We recently shared an analysis article on LinkedIn looking at the expected growth of AI tools for manufacturing, and the growth is projected as staggering. And of course, it makes sense because truly these tools have the potential to really transform what is happening on the factory floor, right? But the reality usually looks a bit more like this, right? If you've dabbled with this, you might be able to relate. Some sad emojis here indeed. You may have downloaded one of these platforms before, and these are the stories that we hear time and time again, right? People know the potential, they try to get it to work, they buy some cameras, they set up one of these tools, and then it just ends up being, quite the awful experience. And it usually comes down to 3 main problems that we see. The first one being data, right? While these platforms or many of these tools and approaches out there promise to not require a lot, and that is a true claim, if you are talking about just getting started, yes, then you probably don't need much data. In reality, they're going to take a lot, right? If you want to achieve high accuracy, if you want to achieve a repeatable, fully robust, well-working, future ROI guaranteeing system, you're going to have to collect a lot of data. You're going to have to collect a lot of sample images, a lot of sample defects per each category, per each kind of defect. All of this has to be captured, which can come with its own challenges. Maybe you don't even have that many products or defects in a catalog yet that would be sufficient to feed this kind of system. It can be quite a headache just to get started on the data, right? And then secondly, while it seems to be relatively easy, it promises to be easy, it actually ends up taking quite a lot of manpower because, again, someone has to do it, right? These images don't just collect themselves. It actually means that someone has to monitor what's going on the production line. You have to select the samples, curate the samples. You have to first do the manual testing, the manual measuring, categorization. Then you have to capture the training data in a standardized fashion. You have to label it. You have to classify it, and so on. So it's actually quite a lot of people, quite a lot of manpower that is also required as one of the main resources. And then, of course, none of that can be done in a day. So usually, this is what is also needed: a lot of time, right? So this is what we see quite a lot of frustration, a lot of people that we talk to. We experience a kind of burned ground situation where we talk to them, we ask them, hey, have you tried yet? And a lot of manufacturers nowadays say, yeah, we've tried, and we ask them, and how was it? And then they're like, it's quite challenging. We got it to work now. On one of our lines, but boy, we're really hesitant to bring it to the next line because we spend so much more time and so much more resources on getting it to work. We actually had to hire another AI engineer who is now working full time just to keep up with the system. So yeah, while it is made to look very easy, it can end up actually being quite difficult. We call this the last mile problem, right? And the last mile is to get over that last edge. So if you go for one of these platforms or one of these tools, or sometimes it's complementary with the hardware that you can purchase, achieving something like 80% level of accuracy is relatively straightforward and is often producing a very promising case where you think, okay, this is looking good. We're almost there. Right? But then that push from the almost there here to the 99%, that, as you can see here, right, that usually takes a lot more data, takes a lot more resources, and is an exponential increase in these resources. So this is the kind of diagram that you will see in a lot of these platforms, or something along these lines. Some training data, some labeling, some review, retraining, and so on. And then easily you get out a nice AI model that can do your inspection. But hidden in this is again these three resources that it is very hungry for. Lots and lots of time, lots and lots of manpower, and lots and lots of data is required. And what this approach usually does, and what most of these tools do, is they externalize the challenge and the difficulty to you. Because of course, if they were to internalize it, they would have to have their engineers sitting there doing all of the work for you. So instead here, it's on you. And then also the responsibility lies with you, right? Because if you don't achieve the level of accuracy that you're setting out for, well, I guess you just didn't upload enough pictures. I guess you didn't do enough labeling. Maybe you should have trained a couple more cycles, right? So it's a convenient approach to maintain if it's your responsibility, right? But it doesn't have to be this way, and we'll get to that in a second, right? So this is how you would get started with the conventional systems, right? Lots of data, lots of labeling, lots of time, and then over time, one cycle, second cycle, third cycle, you get better and better. But how do you get started with us? How do we differ at Zetamotion? How can we make this headachy problem easier? Right? The way it works is by mimicking the way a human works. Right? So if you imagine training a new quality control worker, a human who's actually on your production line, who inspects the products just as quality inspection has been done for the last 100 years. You don't show that human 1,000 labeled pictures, right? So let's say you have a human and you have a worker and you are inspecting, you are producing computer mice, right? You want to produce a number of these kind of mice, and they sometimes come with defects because there's some unforeseen circumstances on the production line that sometimes create a little scratch or a bubble or a dent. Now, what do? Right? You don't sit down and give the human all of this training data that is required for conventional AI training. Right? Instead, you show one or two examples. Right? So you sit down, you have a seasoned QC worker sit down and show a couple of examples and explain. Right? Okay, look, there's this scratch here. And the scratch sometimes happens when humidity in the factory is too high, and because of that, one of the production steps has a bit of a hiccup, and one of the wheels misaligns, and then you get these kind of scratches in there, or sometimes the bubbles happen on the coating. And you keep going, you go through the defect catalog together, and at some point into that conversation, the worker will go, okay, I got it, I understand, I get what you mean now, right? And what has happened there is what we call semantic understanding, right? It is understanding the principles of the kind of defects that you are looking for. And if tomorrow you show the worker a mouse that looks slightly different, maybe it has a different shape, or it has a different type of coating on it, or maybe your latest customer wants to do some kind of promotion and it carries some character from sports or somewhere, right? The human can still do the inspection. Human can still extrapolate, can imagine what the kind of defects that he or she has learned about would look like on this new type of mouse, right? But what would happen with a classic machine vision system? Right? Maybe you've seen this case. Maybe you have first-hand experience of what it feels like because you've ended up with this, right? With the frustrated guy. Oh boy, why is it not working, right? And we have a number of real world cases like this in the conversations that we had with manufacturers. Like there's a steel manufacturer in the UK. They are making large metal sheets that are coated and that are going in a second step, they're going to be made into building cladding. So it goes onto the facades of big buildings. And they bought a machine vision system that was doing an adequate job at inspecting their flat coated metal sheets. But their customers were asking for something more interesting, right? There was a lot of demand in the market for embossed building cladding. So they started, or they upgraded their production line and are almost exclusively making embossed patterns now. So you have to sheet the metal sheet and it gets some embossed patterns on there. And as you may expect, the machine vision system they had in place flags everything, all of these patterns as defects, right? So every single bit of pattern is flagged as a potential defect, effectively rendering the entire system completely useless, right? So these guys, they try to go back to the original vendor and ask them, can you help us? And the vendor said, nope, sorry, that's what you bought. That's what it can do, right? And in many cases, if you build the system actually yourself, it would mean that whenever you have a new kind of mouse, let's say, if you're the mouse producer, if you have a new kind of design, you would have to go through this whole cycle every time again, right? Lots of data, lots of labeling, one cycle, second cycle, slowly creeping up this accuracy. Right, so that's how it would usually be. But how is it different for us, right? It's different because we have built our inspection platform on the principle of synthetic data. Nowadays, it's not the newest kid in town anymore because you can see it in several places. It was first pioneered in attempts of making autonomous driving a reality because it was too difficult to capture the entire world. One of the earliest adopters was Google, trying to synthesize a lot of data using game engines to train their virtual cars. But the idea is really that you generate the data, the training data, by yourself, right? High fidelity, extremely realistic, creating a data set that would otherwise require lots of data, time, and manpower to capture, right? And that's what we have been building since 2019, setting up a system that can do this very, very easily and very, very accurately, and is built for AI. So it is not made to fool humans, but it is made to create the optimal training data for an AI system to not require additional data. And because we have this system, we can offer these items that we have on the right here, right? That's why we can get started with truly minimum input, right? So where the other ones say just a couple of pictures, for us it's a single scan. So if you have an inspection station from us in your plant and you have a new variant that you want to onboard, you just run that through the system, and in the dashboard of our platform you would have a scan button in the inventory. You run it through. That is sent to us. You specify if there's any new types of parameters that you need inspected on this kind of variant. And then we take over that responsibility of making it work. So where the others are externalizing that difficulty, we internalize it. We make sure that the inspection works, and it works at extremely high levels of accuracy. So if you have a new mouse, you put it in the station as you would inspect your previous mice. You go to the inventory page, you hit scan, it runs through, you specify your new parameters if there are any, and in less than 24 hours, you can start scanning that new product at the same level of accuracy that you're used to, right? That's the promise that we make, and that's what is made available and made possible by our synthetic data approach, right? So how does it work? What does Spectron, which is our flagship product, encompass? It encompasses the entire pipeline, right? It's not just a synthetic data tool. It's not just a machine vision tool. It's a full QC platform, as in, if you have Spectron in place, you'd have the onboarding of products where you specify and you teach us the same way you'd be teaching a human worker, essentially, where you specify your defects and you set up the products that you're inspecting. It does the inspection itself, of course. It covers all sorts of parameters that you would have with a human inspector, so including not just anomaly detection and flagging, but really specified defect detection, classification, measurement, parameters like clustering, how many of what type can be in what area, what can be masked out, object verification, if there's items that need to be placed there, like certain markers or certain components, OCR reading, anything that is essentially anything that a human would do with his or her eyes or with a measurement tape or magnifying glass. The system is made to do. The system is also as close as sensor agnostic as you can get, which means that for a given job, we would, well, if you already have vision hardware in place, we can just interface with whatever comes out of that system. But let's say if you're getting started from scratch and you're currently still at manual inspection mode, we would be there to help figure out what is the right kind of hardware, what is the right kind of sensors that you require, and then put that together for you, as in what you get is essentially a turnkey solution. You get the full spectrum, including the hardware, right? We determine what is the right kind of sensors, what is the right kind of parameters or what is the parameters that you need, and what sensor can address that. Put that together, get that in place in your facility, make sure it works flawlessly, and then capture all of the parameters that you require. Because we know that if you have a system, or if you have a partial system that can do half of the parameters that you need to look out for, then you're still far from automation, right? If you can address only A, B, and C, but D, E, and F, you still have to do manually, then how much do you win, right? It's quite limited. So system is meant to be maximally flexible, covering the most parameters you need, and it is meant to be customized as well. So if you have a particular challenge, it is very easy for us to use the tools of the platform to put together a custom solution for your specific QC requirement. So how do we differ, and why are we the aspirin to your headaches? In summary, where conventional approaches require thousands of sample images, we work off of one scan, right? Where usually each of these images would have to be labeled painstakingly. We don't require any of this kind of labeling. All we require is the kind of teaching you would do with a human in an actual conversation. You walk us through your samples. You walk us through the examples of the kind of defects that you have, right? Where others may take months or years to deploy, we usually work on a scale of weeks to months. And where a variant onboarding can take several weeks, we promise to do that in less than 24 hours. And as I said, the challenge is usually externalized. If it doesn't work, it's your fault. We guarantee the performance and accuracy and make sure it works, and continue to do so indefinitely. Right? Our model is one of lasting partnership, where we make sure that it continues to deliver what you require from it. And lastly, in terms of scope here, usually the model, unless it's an actual solution provider, which tends to be extremely expensive, you only get the components, and then you have to have your own engineers again to make up for the rest, right? You might get just the hardware or just the software, and then you have to source the hardware, or just the hardware, and then you have to find the right kind of software to address your problem. And our approach is to have the full solution available for you. Right. So this is a little bit of a visual of how it actually works, or how it looks like, to give you a bit better idea of what this synthetic data translates to. It's really like a human works, right? If you ask a human to learn about a product, and then you might ask the same human to draw alternatives, right? The human would also synthesize how else this might look like, and that's exactly what we do. And this is especially useful when you have difficult surfaces, right? In a second, we're going to get to some of the slides that outline where this kind of approach shines in particular. And one of them is non-uniform surfaces. So it's quite easy to, or quite straightforward to use machine vision when you have beautiful, uniform, polished items, maybe something that comes out of a CNC mill, and you're not going microscopic, because then the surface is perfect, right? And it always looks the same, and it should always look exactly the same. And defects are quite straightforward. But if you have something like brushed metal, or you have a composite material, or whatever you're producing is being coated or hardened or goes through a furnace, there's always this kind of element of kind of organic chaos that is happening on the surface, and that can be very difficult for a machine vision system to deal with if you don't give it, well, a huge amount of data, right? Because it has to account for all of this variation. But if you have a synthetic data approach, that can be solved, because you can synthesize it. You just need a seed sample scan, and from that we can come up with millions of variations, which are extremely high in their similarity, if you will, right? It's extremely close to reality, and we can create this universe of variations that the system can be trained on, much more than you could ever actually capture in reality, which allows us to achieve high accuracy. And the same works with the kind of defects that you're showing us. Right? The ones you see here are quite crude, so you might wonder, okay, this looks very obviously generated, which it is for visualization purposes. Right? But the idea is that the defects that you show us, even if it's very limited, is sufficient for us to generate so many kind of variations, how else that might present itself, that the system can account for whatever it encounters and can accurately measure, classify, even something that you have never shown it, right? Even if it has a weird shape, the kind of scratch that you're looking for. And if we do come across something that is completely unknown, that is such an anomaly that it does not look in its phenomenology in any way like anything that you have ever shown us, the system can flag that and ask for an operator to check, okay, what is that? And to ask for input on what exactly this is, right? So if you have something like this, if you have some kind of road runner that somehow appears on your part, the system would flag that something is going on here, and ask for assistance. And that kind of input then again can be captured by the system, and we can collect this and feed it back into the system for future reference. So this is also a tool of knowledge preservation and knowledge transfer, if you will, because over time, even the strangest items will be caught by the system and will be incorporated for future reference. And then from there, we get the full severity analysis, all of the parameters that you require, and package that in a format that suits your purposes, right? And the kind of reporting that you require, we know that usually every product has, or every manufacturer has some slightly different way they report it, or your customers require a slightly different way of outputting this, and the system is geared to account for that. And if you need some manual input there as well, that is also part of the system. Right. To be mindful of time, and I want to have enough time for a couple of QC, I'll be quick on the rest of the slides. But this is what the system actually looks like, the dashboard, some of the overview frames here. When you're scanning, you get some idea of the statistics of what's happening as well. This is here's a screenshot from an actual sample customer of ours inspecting panels that go into aircraft. And yeah, you know what's going on. You can collect the statistics of what's happening on your production line. And even if you don't have multiple stations yet, just having full, complete scans of every product can be extremely powerful for your factory already, because you can bring back these insights on the statistics and optimize your production line. So these guys, they actually currently have only an end-of-line inspection system, but from the insights, they were able to increase their yield by about 5%, which is something that we're very proud of and very happy that they are happy about it and are happy for us to share their use case as well. Right. Yeah, there's some more impressions of what it looks like, including defect mapping, the ability to look deeply into every single defect that has been collected, potentially also override, offer additional input, and so on. Now, lastly, before I open the floor to questions, where does our approach apply in particular? Now, there are a lot of saturated industries already, and these tend to be the low-hanging fruit ones, where you have beautiful products, straightforward cases, data is available, and it's economically viable to do this whole cycle of capturing lots of data and making it work. But especially in these three categories, when there's very limited data available, because there's not that many products being produced, or there's so few defects even happening, it can be extremely challenging to just generate the data set that is required to get started. Right? Equally, when you have products that are very, very noisy and non-uniform. This is from another pilot with the largest roofing manufacturer in North America. They are making roof shingles, which is a composite material from glass fiber and then bitumen and paint, as well as sand granules. So every single one looks completely different. And you can imagine that this is a complete nightmare for classic machine vision, because everything could be a potential defect. Right? So here you would require just an insanely large amount of data to account for all of the variation. This is another area where our system shines, because we can generate that data ourselves. And then lastly, when you have agile manufacturing, lots of variations, maybe lots of custom jobs, many production runs only have hundreds or thousands, not millions of products per line, but still you would have to spend lots of time on the inspection. That is another case where we can help, because it's so easy to onboard quickly. Right? So lots of variants, noisy products, and then a lack of available data. Right? This is the reference case I spoke about. These guys are making panels that go into aircraft. And as I said, inspection was a huge bottleneck for them. We reduced what used to be more than 30 minutes of manual inspection to a 30-second scan, from putting the sample in there to having the report out. And as a result, have been able to increase their yield by up to by about 5%. Okay, and then truly lastly, before we go to the Q&A, another ability of our system, or something that the ease of onboarding unlocks, is saturating production lines with inspection stations. Because usually a product looks slightly different at each production step, which means you would have to do the same cycle every time. You have to capture data, samples, and so on for every step of the production line, and that just, it's just impossible. But if you don't have to do that, and you just have to give us a few samples or one scan per production line step, you can actually have inspection stations throughout the production line, and then we can do some really cool data magic, because we can correlate what we see at the different steps, and we can give you even predictive troubleshooting advice. If we see something that doesn't even look like a defect yet at stage A, but we can predict that with a certain probability it will become one at stage B, giving you the chance to take action early. Right. Okay. There's a couple more slides, but I think I want to get to the floor. Let's see if there's some questions that I'd be very happy to address. So please, well, once again, I have to copy out and we also have a few questions that we have pre-prepared, but yeah, please do go to the bottom right and use the Q&A function, and I'm hoping there will be some interesting questions coming through. Let's give it a, there's, okay, here's one. Apologies if you addressed already. Oh, wait, where did it go? Here it is. Okay. Can you inspect on or offline? Both. So the station you can either have an independent inspection station into which you load the product separately, and then pull the data out of that for your own further management, or we can incorporate in your production line. There's sometimes some challenges with regards to the environmental difficulty there, as in, sometimes production lines can be hot, noisy, lots of vibration, dusty, and so on. But these are hardware challenges that are quite straightforward to solve usually. And because we are very flexible on what hardware we deploy, we would just work with you to identify the best kind of hardware that solves whatever environmental challenges we have there, and get something in place inline as well. So it's inline and offline both, depending on what you require. And then there's a second question regarding onboarding. Are you referring to the system needing to retrain when presented with a different but similar product configuration, or is it onboarding per defect type and then can apply to a wide range of configurations? It depends. So if the variation is not very far from the current variation, there might not be any requirement for retraining at all. We can, in such cases, we would just run a couple of tests. If you desire, we can also have a full verification test set, of course, that's statistically proven that indeed it achieves what you need it to achieve. But for pragmatism and practicality, it usually isn't required to do the full scientifically accurate test, but we just check whether it works. And in that case, quite often there is no additional onboarding required. But if you are changing significantly, right? So if you, for example, these guys, the panel makers, right? You can see the difference between this design and this design. So they're changing from diamonds to these, whatever that pattern is, right? They have a lot of these pattern changes because their customers want different designs for this product. And then we usually do a retrain. So they scan one of the new panels with the new designs. We teach the system that this is the new design to account for, and it can do that. The defects, you don't have to provide us new samples, right? Because the defects usually are very similar, unless there is a new kind of defects that you need us to classify. You just give us a scan that carries one of these new defects. So for similar cases, probably no retraining required. For significant changes, we require one onboarding scan. We onboard it for you, and the next day you can start inspecting it. Can the system only scan 2D flat panels, or can it inspect 3D products? The system doesn't really care. So mostly this is a hardware challenge or question. Of course, it's much easier and straightforward to do flat products, because you can mostly get away with area scan cameras and maybe something like a laser line scanner. And 3D objects can be a bit more difficult. You need a turntable, or you might need some kind of robotic solution to make sure you are capturing everything. And sometimes we come across some complex shape where you even have to kind of insert a tiny camera, almost like a borescope, inside a cavity to inspect on the inside. All of that can be done, and we're happy to incorporate that as well. So long-winded answer. The short answer is it can do 3D products as well. The system doesn't really care. Wonderful. Let's see. Let's give it another minute. Very good. All right. Looks like we have the most pressing questions answered. I hope this was useful to you. And of course, if this sounds like an interesting potential for you or anyone you know or your family, do not hesitate to reach out. We're always happy to hop on a call, find out about what you're looking at. No matter where you are in the stage, if you're just getting started, if you're already dealing with some of the AI headache, we're happy to have a chat and see what we can do for you.
All right. Thank you so much, everyone.
Thanks, everyone.
All right.
Those are for you. Thanks, everyone.
Bye.